Section 3.7 talks about polynomial and rational inequalities. So this is no longer linear inequalities. Linear inequalities, we treat a linear inequality like an equal until you multiply or divide by a negative. You have to switch the inequality symbol. Once the power on x exceeds 1, or you're dividing by x, that's no longer linear. And treating that like an equal is not possible. So when I say 1 would the product of those 4 terms be less than 0, you can't say let's set the first one be less than 0, the second be less than 0. It doesn't work that way. You have 2 options, and I'm going to show you both options on every problem in this section. One option, okay, why is that not registering? One option is to use a test line. This is 0 at 2. This is 0 at 1. This is 0 at -1. And this is 0 at -3. Included. One way of doing this is for you to pick a test point to the left of -3. You're only interested in the sign, if it's plus or minus. So one way of doing this is for me to say, well, let's take -5 or -10. If I replace x by a -10 or throw a -10 in there, -10 minus 2 is negative. -10 minus 1 is also negative. -11, that's negative. -10 plus 1 is negative. And -10 minus 3 is negative. If you multiply 4 negatives together, that would be a positive. A point between, maybe I should space those out just a bit more. I didn't pay attention to this part. So here. Then we had -1. So let's say I pick a -2. -2 minus 2 is negative. -2 minus 1 is -3, that's negative. -2 plus 1 is -1, that's negative. -2 plus 3 is a positive. 3 negatives multiplied will yield a negative. Then we have to worry about, we said 1. So a point between a positive and a negative is 0, that's ideal. Negative, negative, positive, positive. So if I have 2 negatives multiplied, remember the positives don't change anything in multiplication, the product will be positive. And a point to the right of 1, say 3, 5, 10. 3 minus 2 is positive, doesn't count in multiplication because when you multiply by a positive, the sign doesn't change. 3 minus 1 is positive, so I could list them. 3 plus 1 is 4, that's positive, and 3 plus 3 is 6, that's positive. So I'm looking for, where is this? Let me erase all the cluttering part. Where is this less than or equal to 0? Well, a value is less than or equal to 0 if the value is negative. Where do we have this being negative? It's right there. And that was it. Just one place. When I move this, I forgot to, because those are included. So my answer here would be, to this problem, from -3 to -1. That would be my answer. An alternative is to sketch a graph of this. This is x to the 4th. It has 0 at 2, 1, -1, and -3. And this behaves like x to the 4th if you multiply those out. And the multiplicity on all of those is a 1. The y-intercept, if you put 0 in for x, -2 times, that's negative, that's a positive 2, times 1, that's 2, times 3, that's a 6. Since this is multiplicity 1, okay, there's something I'm not getting. Why is that not working? Let me see. 2 and 1. Oh, my mistake. That's not a 1. That is a 2. So this equals 0 at 2. This equals 0 at 1. I missed one more point. Okay, that's what it is. This was a 1. When I moved this, I missed the point 2. I didn't pick anything between 1 and 2. So this here was to the right. I picked 0. I didn't pick anything between 1 and 2. How about 1.5? Remember, I don't want the value, just the plus or minus. 1.5 minus 2 is negative. 1.2 minus 1 is positive. 1.5 plus 1 and 1.5 plus 3 is positive. There it is. So I messed that part up. So it's negative also here. So I should have said this is negative union with 1 to 2. I thought something was missing. Well, look at this graph. Where's this graph negative? I could have gotten to that answer a lot quicker if I would have graphed it instead. To demonstrate that, I'm going to sketch the graph of the second and then do the test line. If I want to know where this is bigger, x cubed is bigger than this sum, well, I need to find the zeros to do my testing or to graph it. Factor x squared out. That's sine a 9. So this will be x minus 2 into x squared minus 9. So x minus 2, x minus 3, and x plus 3 is bigger than or equal to 0. Alright, well, I'm trying to figure out where is x minus 2 into x minus 3 into x plus 2 is bigger than or equal to 0. I could do a test line. That's fine. Or, if I really got the previous sections down, the zeros are 2, 3, and negative 2. The y-intercept is negative 18. This behaves like x cubed. Multiplicity is 1 on each one of those, right? I'm sorry. The y-intercept is 0, 18. So, multiplicity is 1 on every of these 0. There it is. Where's this graph bigger than or equal to 0? Bigger than or equal to 0, if you have a number line, a quantity is bigger than 0 when it's positive. Where's the graph positive? Well, it's above the x-axis. I could say the answer is from negative 2 to 2 union with 3 to infinity. There it is. Done. A lot quicker, a lot more efficient than me picking a test line. Or I could pick a test line. I could say, you know what, where does this equal 0 at 2? This is 0 at 3. Let's make that 3. Let's make that a 2. And that a negative 2. Again, this is not done to scale. It doesn't matter. Let's pick a point to the left of negative 2. Say negative 3, negative 10, negative 100. Negative 10 minus 2 is negative. Negative 10 minus 3 is negative, and negative 10 plus 2 is negative, negative 8. 3 negatives will yield a negative. A point between a negative and a positive 0 is ideal. 0 there, there, and there. That will be negative 2 times negative 3 times positive 2, which is a positive. A point between 2 and 3, 2.5. Remember, I don't want the value, so 2.5 is not that bad of a deal, because all what I want to know is, if I put a 2.5 in there, 2.5 minus 2 is positive. 2.5 minus 3 is negative, and 2.5 plus 2 is positive. That will make it a negative. And a point to the right of 3, say 10. 10 minus 2 is positive 8, that's positive. 10 minus 7 is positive, so here we have all positive. Where's the graph, and is it included? It says bigger than or equal to 0, so those points are included in my solution. And if I look at where is this bigger than 0, positive, it's right there and right there. And as you notice, I already have that listed. And I'm going to sketch the graph of each of those first. The graph gives away what you need. So if I look at the next problem, well, this one doesn't factor, right? So, but I know the factors of P, which is 1 and 24, 2 and 12, 3 and 8, 4 and 6, and the factors of 4 are 1, 2, and 4. So we know how that works. Plus or minus all of those divided by all of those. So I need to factor it, whether I want to use the test method or the graph. I'll go for 1, 4, 9. 9 plus 24 is 31 minus... No, that's not going to work. How about negative 1? If I test negative 1, that's a 4 minus 5 minus 22 plus 20 plus 24. 44, 48, that's not going to work either. Does 2 work? So again, I'm trying to factor it regardless of which method I want to use. That's 4, 3, 2, 1, and 0. 1, 5. Okay. 4, that is 8, that is 13, that is 26. That's a 4, that's an 8. That's a negative 12, that is a negative 24, that's a 0, it worked. Does 2 work again? 4, 12, 25, nope, that's too big. How about negative 2? 4, negative 2, negative 8, 5, negative 10, that's a negative 6, that's a 12, that's a 0. Very good, it did work. Oh, and this is quadratic. So this is actually, I'm looking at x minus 2 into x plus 2. And if I look at 4x squared plus 5x minus 6, that factors into 6 minus 4, that's not working. So 4 and 1, 2 and 3, 3 and 2, oh, there it is, right there. That is 8 minus 3, 8 minus 3, positive 8, negative 3, so 4x minus 3 and x plus 2. So I have times 4x minus 3 into x plus 2 bigger than 0, or simply x minus 2 into 4x minus 3 into x plus 2 squared is bigger than 0. Alright, well, don't need any of this mess. So, how does this work? If I go for a graph, it's fairly quick. The zeros are at 2, 3/4, and negative 2. The y-intercept is 24. This is x to the 4th. I have a multiplicity of 2 on negative 2. So around this, it should look like a parabola. And multiplicity 1 on each of those. There it is. There it is. Something like that. And this, I should make it just a smooth curve. Okay, where is this graph? Greater than 0. Well, greater than 0. It is from negative infinity to negative 2, union with negative 2 all the way to 3/4, union with 3/4 all the way to infinity. The reason it's parentheses because none of these are included. If you want to make a a test line, that's fine. X equal 2, not included. X equal 3/4, not included, and x equal negative 2, not included. So when I pick a point to the left of negative 2, let's say negative 10. Negative 10 minus 2 is negative. Negative 40 minus 3 is negative. I'm not going to use this for anything because whenever you square a quantity, it's always positive. And in multiplication and division, sign-wise, a positive doesn't change the plus or minus. So two negatives will yield a positive. A point between a negative and a positive, 0 is ideal. Negative 2, negative 3, that's a positive as well. A point between 3/4 and 2, 1. 1 minus 2 is negative. 4 minus 3 is positive. And the last one is positive. And to the right of 2, say 5. 5 minus 2 is positive. 5 times 4, 20 minus 2, 3 is positive. So where is this again? Positive. It's positive in all of these regions, which are right there. So the graph, and of course I'll accept a graph on your test or the homework. That's a lot more efficient. You don't have to do both on the homework. You could just do one. So let me just move this a bit down. How about, again, temptation is to cross multiply. Definitely not the way to go. I'm just going to shift this a bit and close it. Here we go. Okay. That does it. Okay. So if I want to graph this, well, I know how this works. There is a vertical asymptote at x equal 3. 1, 2, 3. There's a horizontal asymptote the graph crosses at, so 1 vertical asymptote x equal 3. You really don't have to write those. You only have to do that if it's a sketch a graph. Here it's your option. If you let x equal 0, you'll get negative 5/3, negative 1, negative 2, negative 5/3 is about right there. And 4, the top equals 0 at negative 5/2. So anytime you rescale the graph, you have to show you should label there and there. I want to know, where is this graph bigger than or equal to 0? Bigger than or equal to 0 means positive. There is the line. Y is positive above. So it's these values. It is from negative infinity to negative 5/2 greater than or equal. Union with 3 to infinity. What's wrong with this is that even though that says greater than or equal, I can never include the 3 because 3 is in the denominator. So that would be parentheses. And that would be my answer. Now if you want to make a chart, you can, because multiplication and division behave the same as far as plus or minus. Where does the top equal 0? At negative 5/2. Where does the denominator equal 0? At 3. Since it's included, but I can never include the denominator because that will make the denominator equal 0, and that's not allowed. A point to the left of negative 5/2, negative 10. Negative 20 plus 5 is negative, and negative 10 minus 3 is negative. That would be a positive. A point between a negative and a positive is 0. Obviously, I'll get 5 over negative 3, which is negative. And a point to the right of 3, say 5. 20 plus 5 is positive, or 10 plus 5 is positive, and denominator 5 minus 3 is positive, and there it is. And where is this positive? It's positive here and here, which I already listed. And what if I'm looking at something like this? This will be the last problem I'm going to do. Well, 1 over x minus 1 over 2x minus 3 is less than or equal to 0, so get a common denominator. The one thing that to do is to cross multiply. Multiply this by 2x minus 3. and multiply this by x. So I'm looking at 2x minus x, that's x minus 3 over x into 2x minus 3 being less than or equal to 0. If I decided to graph this, that's fine, you could do that. Again, you don't have to do both of these on the homework, you just do one of them. I have a vertical asymptote at x equals 0. I have a vertical asymptote at x equal 1.5. So here I'm not rescaling. And we have a horizontal asymptote y equals 0. Putting a 0 in for x, that's not possible. We have an x-intercept at 3. So here we need test points. Maybe, again, if I have a choice, maybe I will just stick with the test line for this instead of me trying to do, I'm going to do both for you, like I said. But if I had a choice, I would pretty much maybe choose this. Here I have to choose points anyways. Well, choose a point to the left of 0, say -1. Well, aren't you doing that here too? -1. You just want to know if it's positive or negative. And -1. -1 minus 3 is negative. And -1 there is negative. And a -2 minus 3 is negative. 3 negatives will yield a negative. The graph will look like this. But do you see that you're doing this anyways? A point between 0 and 3/2, say 1. 1 minus 3 is negative. A 1 in there that's positive, and 1 in there. 2 minus 3 is negative. Negative over a negative is a positive. And point between 1.5 and 3, well, 1.5 and 3, say 2. 2 minus 3 is negative. A 2 there, that's positive. And 2 times 2, 4 minus 3 is positive. That's a negative. And a point to the right of 3, say 5. 5 minus 3 is positive. 5 is positive, and 5 in the place of the 2. 10 minus 3 is 7. That's positive. There's the graph. So the graph-wise, but the catch is, when I look at this, I should know it is less than or equal. X could be a 3, that's not a problem. But since x equals 0 is from the denominator, and x equals 3 is from the denominator, that I can't have. I'm trying to figure out where's this being less than or equal to 0, meaning negative. It's right there, and it's right there. So my answer would be negative infinity to 0. Similarly, I could put here and here. Union with 3/2 to 3. The only included point is the 3 because that's not in the denominator. And that's pretty much it for this section.